So now we go to the 3 by 3, all right? 3 by 3 is much more complicated, and I'm not going to complete the whole question for you. I tell you the process, and after that, you proceed it as your homework. I will give you the answer the next lesson, all right? Not the next lesson, I mean the next week, next Friday, most likely, okay? So now we go to this one, case 2. The characteristic equation determinant for this case 2, 3 by 3 matrix. All right. So the matrix that I'm talking about here is in the form of A equals to, in the form of A, B, C, D, E, F, G, H, I, like that. All right. So when you find the characteristic equation determinant of A minus lambda I equals to 0, this is a cubic equation. All right. Only real and distinct eigenvalues are considered. The process is no difference from what we did just now. Okay. The only difference is now I added one extra row and I added one extra column. And I told you, when you write down the determinant of A minus lambda I, only the A, E, and I are affected. The rest, you just need to copy. All right. So as an example, let's look at question number 2. All right. Question number 2. It is given that A is equal to 1, 0, 0, negative 1, 2, 0, negative 2, 1, negative 3. Write down the eigenvalues of A and find the corresponding eigenvectors. So it's the same thing lah. You have to find the characteristic equation first by considering the determinant of A minus lambda I, followed by solving the cubic equation, followed by finding the eigenvectors. All right, so we are going to look at this vector, yeah, A. 1, 0, 0. No, I have to remember the column first. Sorry, the diagonal. 1, 2, negative 3. 1, 2, negative 3. Question 2. Okay. So question 2. I write down A minus lambda I equals to. So you have 1, you have 2, you have negative 3. So I always write down the diagonal elements first lah. So I know that this one is 0, 0, 0. Okay. Then after that, you have negative 1, negative 2, first column. Negative 1, negative 2, first column. Then after that, this is 1, right? Yeah. Okay. So I want to find the determinant of A minus lambda I. And I have to set this determinant equals to 0. So you have to set determinant of A minus lambda I equals to 0. Okay. I think I told you before in the previous lecture, or maybe in FP1, yeah. I said if this is a triangular matrix, can you see that the 3 zeros here form a triangle? This is what you call the triangular matrix, right? And if this is a triangular matrix, the determinant of this matrix can be found easily by looking at the product of the diagonal elements, which means you have 1 minus lambda, 2 minus lambda, followed by minus 3 minus lambda equals to 0. Okay, so solving this equation, you will get lambda equals to 1 or 2 or negative 3. It's quite obvious lah. So you have 3 eigenvalues, and therefore you have 3 eigenvectors. All right. So now I define first here, because I'm going to use the notation. Let E I be the...
Excuse me, sir.
Yes,
Can you admit Liang?
Li Yang.
Yeah.
I thought I admitted already. He got disconnected just now. Okay, so I define let EI be the eigenvector of A corresponding to the eigenvalue. So I told you, eigenvalue, eigenvector, they coexist. They coexist together, all right, to the eigenvalue lambda I. So now you have 3 cases, I equals to 1, I equals to 2, and I equals to 3. So I can start with I equals to 1. So case 1. So you have to find the eigenvalue separately. Yeah. So case 1, you have lambda 1 equals to 1. I will do this one for you. Then you have to do case 2 and case 3 for me. The process is the same. Okay. So lambda 1 equals to 1. So therefore, I have to consider A minus lambda I. So A minus lambda I means the matrix in the form 1 minus 1, you get 0, 0, 0. Then you have minus 1. Then you have 2 minus 1, you get 1. And then this is 0. This is negative 2, 1. Minus 3 minus 1, you get minus 4. Okay. So now I want to solve the equation. So solving the equation means you have to solve 0, 0, 0, negative 1, 1, 0, negative 2, 1, negative 4 times x, y, z, and then you set this equal to 0, 0, 0. So you have to solve the simultaneous equations. So I will have the 3 equations here. So I'll write down one by one the 3 equations. So therefore, the first equation is 0x minus y. So you have minus y minus 2z equals to 0. That is the first equation. Then you have the second row. So you have 0x, 1y, 1z. So you have y plus z equals to 0. This is the second equation. Then you have 0x, 0y minus 4z equals to 0. So you have the third equation. So from the third equation, clearly you know that your z is equal to 0. So when your z is equal to 0 from equation 2, backward substitution, equation 2, y plus 0 equals to 0. So you know that y is equal to 0. You go to equation y, 1. So you have minus y minus 0 is equal to 0. You still get back y equals to 0. Means that this system is consistent. All right. It is consistent with y equals to 0. You see the two y values here, you get the same value. So this is still consistent. Therefore, our solution is in the form. Therefore, our solution is x, y, z, right? And this is the vector lah, x, y, z. So x, y, z is now in the form y is equal to 0, z is equal to 0. Only x is no clue. We have no clue what x is. That means x can be any number. X can be 1, x can be negative 1, x can be pi, x can be negative pi, x can be e, x can be negative e. Okay, so x can be any real value. So I just put it back as x. So therefore, factorizing the x, I get the answer 1, 0, 0. So this is a possible eigenvector. So therefore, eigenvector 1 is equal to 1, 0, 0. Of course, some people say, teacher, I want to choose 2, 0, 0. Okay or not? Up to you lah. Okay. I want to choose the value negative 556, 0, 0. Up to you lah. As long as you make sure your y and also the z are both 0, whatever value of x you choose, it doesn't matter. But like what I told you earlier, because there might be some other questions asking you to make use of the eigenvector to find the inverse matrix, you better use the best answer. So what do I mean by the best answer? You try to make sure the number is as simplified as possible and make sure the answer is not a fraction. Make sure the answer is an integer. If it is not an integer, like just now, for example, you have 1, 1.5 just now, okay? 1 and also 1.5 here. Then you try to make it integer by multiplying 2 and 2, all right? So the 1 multiplied by 2, the 1.5 also multiplied by 2. You try to get integer so that later when you have to evaluate the inverse matrix, that will make your life easier, all right? So the answer, eigenvector 1 is 1, 0, 0. So if I were you, I choose this as my answer. That's all. Okay. So case 2, you will have to do it. And case 3, you have to do it. Okay. So case 2, I think you do it, and then after that you PM me the answer because I have to go for the meeting. I have to prepare for the meeting later. So case 2 means lambda 2 equals to 2. Okay. Then case 3 means lambda 3 equals to -3. So you use the same approach. So you must first go to A minus lambda I. You use this matrix. Then you solve the equation as usual. All right. Thank you. I will send you this file. Okay. I will end the meeting now.
Okay, thank you, sir.
Thank you, sir.
Thank
Thank you,
you,
Mr.
sir.
Lee.
Thank you, sir.
Okay.